So we're going to multiply binomials in this problem. Now the trick is this binomial, this fraction has a square root in the denominator, and you know, having a square root in the denominator is just wrong, kind of like kissing your sister, wrong. So we have to get rid of it, and the easiest way to do it is to think of this as a difference of squares. Now, in a difference of squares, if I do this, you have x minus 2 times x plus 2. When you multiply it out, you end up with x squared minus 2x plus 2x minus 4. The middle terms cancel out, and you just get x squared minus 4. Now, we're going to use that to cancel out that middle term. So, to make this a difference of squares, I want to multiply by 1 in the form of 3 root 7 plus 5. And what you do to the numerator, you got to do the denominator, so we're going to multiply both of them. And so here we go. I'm going to distribute the 5. 5 times 3 root 7. 5 times 3 is 15 root 7. 5 times 5 is just 25. Now, the denominator is going to be a little more problematic because we have to multiply it out here. Now, I'm going to do this a little bit longer just because it's the first problem. The second one I will not. So we have 3 root 7 times 3 root 7. 3 times 3 is 9. Root 7 times root 7 is 7. On that one. 3 root 7 times 5 is going to be positive 15 root 7. So on that, negative 5 times 3 root 7 is negative 15 root 7. Negative 5 times positive 5 is negative 25. And just like our earlier example in differences of squares, this middle term here cancels out. We don't have a middle term. 9 times 7 is 63 minus 25. And 63 minus 25 is 38. I hope it's 38. So it's 38. So here's my denominator. My numerator hasn't changed. So I have 15 root 7 plus 25 over 38. Now I can't do anything with this. I can't simplify the fraction. I can't combine terms up here because the terms are just different. So at this point I am done. So I'm going to shrink this so that you have some reference. And I'll take a look at the second problem. Now, in the second problem, I'm not going to write everything out on the denominator because I know the middle term is going to cancel out. So to multiply out the root 5, we need to use the principles of differences of squares. So I'm going to multiply everything, the numerator and the denominator, by 2 root 5 plus 3. 2 root 5 plus 3. And let's deal with the denominator first, because this time it's going to be a lot easier. So I know that the middle term will cancel out, so I just have to multiply these things together. 2 root 5 times 2 root 5 is going to be 4 times 5. 4 times 5 is 20, right? Negative 3 times positive 3 is negative 9. 20 minus 9 is equal to 11. So this is my denominator. So I'll start my answer over here. So I have 11 in my denominator. Now, the numerator is going to be a little trickier because we have 4 plus 2 root 2 times 2 root 5 plus 3. So, rainbows and smiley faces. 4 times 2 is 8. Root 5, because I don't have any other square roots. 4 times 3 is 12, so plus 12. And then I have my smiley faces. 2 times 2 is 4. Root 2 times root 5 is root 10. Now root 10 does not have any perfect square factors, so I can't do anything with that. Finally, 2 root 2 times 3 is going to be positive 6 root 2. Do I have any similar terms here? That's right, I don't. So I can't really combine any of them. I just have this jumbled mess. So what I'm going to do is I'm going to reorder it in ascending roots. So I'm going to start with root 12 plus 6 root 2 plus 8 root 5 plus 4 root 10. And this is all over 11. Now this is an ugly, ugly answer, but that's the way it is. There's nothing more you can combine. There's nothing that you can cancel out.